Okay, let us, actually, before I go jump into the questions, let's do a little bit of a recap of the things we need to keep in mind tonight as we go forward. So if we want to, there's a couple of different types of circle geometry questions that we need to get used to, and you will see them in context as we work tonight. But it's worth remembering, we often have to prove something as a cyclic quad. And so we use the converse theorems to help us with that. And there are three ways to prove something is a cyclic quad. So opposite angles supplementary, the exterior angle equals interior opposite, or if a line segment subtends equal angles, often students will see that as like, basically you have a butterfly and you show that this angle is equal to that, or that angle is equal to that. Okay, so that's for cyclic quads. For tangents, if you want to prove a line is a tangent, okay, you have two options. The angle between the line and the radius is 90 degrees, or if the angle between the line and the chord is equal to the angle in the alternate segment. So what that normally looks like is if you have a line and then you have a chord, and then the angle in the other segment, sorry, this is a bit big, we're trying to show that that angle is equal to that one. And if you show that, then you know that you have like a tangent, okay, not the best circle, but you get the basic idea. So that is how we prove something's a tangent. And then if we want to prove something is a diameter, the converse, so if we have a line and that line subtends an angle of 90, then we know that that line will be a diameter through a circle. So that's the converse, quick little recap. And then what we have here is our buckets. Now, when I think of my theorems, I need to keep in mind, I remember that I have circles and the center. So circles and the center, right? So that's all these theorems. And we can see probably the most popular one is that the angle at the center is twice the angle at the circumference. So you can see the angles in a semicircle. So that's the one bucket I need to keep in mind. The other bucket is circles and cyclic quads. So that's this bucket over here. So when we see a cyclic quad, we know those are true. And then the last bucket we keep in mind is circles and tangents. And so this is almost like our toolkit, right? Like when we go and do the job of circle geometry, we have to have our tools arranged in our toolkit and preferably arranged in little compartments so that if we want to find something, we find it nice and quickly. Okay, give me a thumbs up if that stuff all looks vaguely familiar to you before we get going. You don't have to know everything, but it's worth just checking, are there any questions or comments about the tools in the toolkit? That's what I want to know. Okay, well, the way to get good at something is to practice. So we need to practice. So let's do it. So to start off with today's thing, we're just going to do a question where you have to, sometimes they say, okay, find other angles equal to X. But if they want to be a bit more sneaky, they can do it like this. So it says, in the diagram, the circle goes through those points. The tangents at B and C meet at T. So this is a common tangent, and basically I have that, I have that. BEC is equal to X, so they tell me that BEC is X, and they tell me that angle D is Y. Then it says, express each of the following in terms of X and Y, giving reasons. So what this first thing asks us is find what B2 is in terms of X or Y or both. So we have to write this in terms of these angles. So I want to let you loose and see what you can do on finding these first two. See if you can find me B2 and C4 in terms of X. Okay. So for Tejo, can you give me a reason as to how you found that? Could you give me, you can even put your hand up and just, you can tell me audibly, but I think you're on the right track, but you need to, okay, tan chord, interesting. Okay, so if Fatejo is saying there's a tangent and a chord, oh yes, therefore this angle over here is x, yes. So we'll just say tan chord theorem. Yeah. What about C4? Okay, Trishan, Abongwe, Emmanuel have all said that C4 is also equal to x. And the reason is, well, tangents from a common point and angles opposite equal sides. So I suppose we should say first, BT is equal to CT, and that would be tangents from common point, because we have to show why we know that's true. And then we can say that's equal to x, and that's going to be angles opposite equal sides. Okay, so can I say tan chord? Well, we did say tan chord theorem. For this one, you couldn't really, could you say tan chord? Oh, you could actually, you're right. Sorry, there. You know what? Fateh is absolutely correct. So you can do it like I did it, but now I'm actually thinking, you know what? You could use the same reason, because look, this is a tangent, that's a chord, and then you can make the x in the same way. So in some ways, the quickest way to do it there would have just been to say C4 is x tan chord theorem. And this is this thing in geometry where there's often more than one way to do it. And thank you for your question, Fatejo, because you didn't just help yourself, you helped all of us. Okay, next one. Let's find t. Can you find t in terms of x? Can you find, in fact, do all three. Try and do all three now. See if you can get T, A, and B. And keep popping your stuff in the chat. Okay, so T is going to be 180 minus 2x. That is going to be because of sum of angles in triangle. Okay, now what do we still have to get? We have to find A. Now what can we do to find A? A is a bit more sneaky, it appears. It's not obvious to me straight away where A is. I have to do a little bit of digging. So Abongwe, I agree that A equals B1, but the problem is I don't know how to connect A to B1. I don't know how to connect to X and Y. That's my problem, is that you're right. So this one is definitely equal. So that one over there is equal to that, but that doesn't help us with the particular goal that we have. Oh, some of you are on the money here. Okay, the sneakiness about this is if I show you this shape, maybe this will help you a little bit. What am I showing you with the blue, my blue highlighting? Yep, it's a cyclic quad in hiding. So we know that this is opposite that one. And so if the one is y, this would be 180 minus y. And we'd say opposite angles cyclic quad. So we've got 180 minus y. Okay, now I think getting b will be much easier because of what was pointed out before that. So Abongwe pointed out that a is equal to b1. So what is b1 going to be? Yeah, so b1 is just going to be the same. And the reason is going to be angles in same segment. And so we know that this one over here would be that. Okay. Awesome, awesome, awesome. Can you use the same reason as for A? Another good question. Let's have a look. You can't, Fateko, because no, you can. You can. You're on the money today. So Fateko said, can I use the same reason as before and say, well, if this is y, there's another cyclic quad that I can look at. And so this could just be written as opposite angle cyclic quad. Because the cyclic quad is not the blue, it's not the turquoise one, it's the one that goes like that. And so you absolutely can. They don't tell you it's cyclic, but you can see for Zama that it is cyclic. And the reason I know it's cyclic, there's two cyclic quads. The one is as vertices over here. Okay, so I'm going to try and make this, you can see the blue dots. And then the other cyclic quad that we just use now is this one. And you can clearly see the vertices are on the edge of the circle. Does that help for Zama? It's a good question. Okay. Thumbs up if you followed this, thumbs down if you didn't. And I think we're almost ready to move on to the next question. Okay. All right. Well, let's move on to this question. So in this question, step one is find other angles equal to x, but let's do a quick little introduction. So QS is the diameter of the circle. So the drawing is a bit wonky, but this is actually it goes straight through. QS is the diameter. AU is a tangent to the circle at P. So let's get my yellow out. So here is my tangent to the circle at P. PQ is parallel to UO. So PQ is parallel to UO. And it says P4 is X. So X is basically just this angle X up here. Find me, with reasons, 3 other angles equal to X. Off we go. Reach into your toolkit and see what you can find. Aha. Yep. Some good things coming through. So people are mentioning tan chords, and I see a tangent and I see a chord. And so for me, the very first X that I noticed is this one down here. And we'd say, I suppose we shouldn't really just say S, we should say TSO is equal to X, and that would be tan chord theorem. What else is equal to X? So people are starting to use the parallel lines as well. And Zian mentioned radii, which some of you might have got away from some of you, but you're right. There are some radii because there's a center O. And so you've thought of the bucket of information you need to keep in mind. Nice spot. So I agree. This one over here must be X. So we'll say PUO will be equal to X because of corresponding angles, but we need to list the corresponding angles. Otherwise, we don't get full marks. So what are they? They are PQ parallel to UO. And then the last one is what? What is the last one that we... Isn't O3 also X? I don't think so, Fateko, because we don't have any knowledge about P3 and Q1. So I like the radii idea for Xi'an. So if I look at the radii, I think that P2 must be equal to X. And we can say radii. And so that would be an X over there. Okay, now on to the next type of question. Prove with reasons UPOS is a cyclic quad. Now, UPOS is, first of all, we need to identify it. So just so my brain can kind of follow what's going on, UPOS. Now, even though there isn't a full thing linking this, that is the quadrilateral that we are trying to prove cyclic. And just because there's no circle going through it doesn't mean it can't be cyclic. We're trying to prove we could fit a circle through it. Now, what tool should I use for the job here? So if I look at this, I definitely am drawn to the butterfly. It feels like there's just so many things that are being connected. And in fact, I see these lovely X's here that remind me, well, actually, I'm just going to use the converse angles in the same segment. So what I write down is I write down that PUO is equal to TSO is equal to X. And then you can just say proven, because you have. And then you can say, therefore, UPOS is cyclic quad. And the reason is converse angles. Let me write this. Angles in same segment. And that's it. Okay. Thumbs up. Sir, what about T? So T or P? Oh, PUO and TSO. TSO. It's a T. That's a T there. Oh, you can use either. TSO and TSO are the same angle, so it's not a problem. All right. Let's let me see if there's another one. Let's do another. Yeah, I think everyone take a screenshot if you want of this. We're going to squeeze in one more plain question, and then we'll carry on after the break with something a bit more exciting. Here is why is this in the way? Okay, let's try and do this one over here. So you're given the following drawing, and it says that PQ is equal to PR. So we've got this side is equal to that one. We know that PQR is 80. So PQR is going to be this angle over here. There are some other things, but basically I want you to find me 3 other angles equal to 80. So just find me 3 other angles equal to 80 and see what you can do. Oh, there we go. Okay, so there's definitely consensus in the chat that R1 is 80, and that's because they've given you these two equal sides, and so it's angles opposite equal sides. And so we know that this one over here is 80 as well. So that's the first part. We still need to find two more. So what else can we find? Ooh, look at you guys coming up with very insightful things. Chop, chop. So there's been recognition in the chat that this thing over here is in fact a cyclic quadrilateral. So there's definitely been recognition that that's a cyclic quad, which opens up certain possibilities. So take a moment to look at that cyclic quad and see if that helps you figure out other angles equal to 80. And then give me your reasons in the chat. So I see a lot of students liking S3. What would be the reason for S3 being equal to 80? I think it is 80. So would say S3 is 80. And Trishan and Zama, I agree, it's exterior angle cyclic quad. So that's an exterior angle. Now we need one more, and I think I saw it in chat, but I'm not sure if everybody's recognized it yet. What is it going to be? It's not going to be R2. Look at the cyclic quad again and see if something jumps out to you. Oh, explain how to the exterior angle. So if we look, can you see that this green thing is a cyclic quad? Okay, so this thing is the cyclic quad. If I extend that side, S3 is the exterior angle. Now, the exterior angle is there. That's the interior one. What's opposite that? It's going to be this one down here. That's why those two are the same. Now, the one thing that I think a lot of you are missing possibly is if I make a little dot there and I make a little dot there, what is the relationship between those two? Maybe I should even, I don't want to write everything out, but can you see that this one over here and this one over here have a relationship? And remember, this one was already 80 degrees. Okay, it's a bit hidden because remember the butterfly can be oriented in different ways. And so what we say is that S1 is equal to 80. And I know that's a difficult one to spot, especially at the speed that I'm going now. But I just want to show you how a lot of students are used to seeing the butterfly going sort of vertically. This is oriented sideways. And so angles in same segment. And so now we have our three things that are equal to 80. Okay, let's finish this question and then we have a break. Isn't R2 in the same segment? No. Okay, good question though, Paul. So the problem with R2 is that it is related to just this one over here. But can you see that the 80 degrees isn't just there? The 80 degrees has some extra over there. And that's why R2 can't be equal to 80. Another great question. And you can see how much we benefit by questions from students because a lot of students are probably thinking that. Are they subtended by PQ? They are. So Fateko has said, what is the chord that is subtending these two 80s? And over here, what you have is you have this chord over here, and it is subtending. Wait, hold on. PQ. That was, this whole thing is 80. Sorry, that whole thing is, okay. So for now, we've got that. Okay, I'm not going to go down that particular rabbit hole right now, but you get how that's the 80, that's the 80, and that's the 80. So let us now try and get, if QPS is 70 degrees, where is QPS? QPS is up here. And they are telling us there. Fruti, there is no tangent in this question. So because there is no tangent in the question, we can't use the tan chord theorem. Okay, I want everyone to find me SRT, STR, and PQS. See if you can find the size of those angles. So where is SRT? SRT. SRT is down here. We know that's 80. SRT. Yep. SRT is going to be 70. Well spotted. So SRT, that was impressive. So if you look at this line here, can you see how this, you can kind of see how that one makes a cyclic quad. And so this over here is going to be 70. So we say SRT is 70, and that's going to be exterior angle cyclic quad. Then we need to find, so we did SRT, STR is the next one. I feel like that's a bit easier though. So if that's 80 and that's 70, this must be 30 because of angle. So we go 30, sum of angles in triangle. Yeah. Then what's the last one we still have to do? PQS. PQS. Oh, here we go. Okay, we know this whole thing is 80. We want to know what the little bit over here is, which is going to be less than 80. So what is PQS going to be? If you look at the drawing, what is PQS going to be? It's just this little bit here. It's going to be 30. And the reason is, you know, that's 70, you know, that's 80. So what's the size of this angle down here? It can only be 30. Sum of angles in a triangle. Okay. All right. I have pushed you a bit past our normal break. I think it's important we stop for a second. We won't do too much Maths 24 today. Okay. So where have I lost you? So if you look at, I don't want to, if I put too much information on this thing, it gets crazy. But if we look at this triangle, what I want to suggest is that that triangle over there, we know that this is 70. We know that this from earlier in the question is 80. So what does this have to be? This is not going to be 80 because there's only 30 degrees left to go around. So this angle over here has to be 30. Okay. Fantastic. Okay, let's do a quick little speed break and then we can go from there. So everyone, cameras on your feet. It's just in case you're wondering why we do this, we know that this resets our concentration. So if we keep just going, we don't remember what we're doing. So it's pointless to not take a break. So even if you're feeling like, oh, I don't want to get up, just do it. Your body wants it. Treat your body with TLC. Okay, let's take 4 breaths. So we'll go in and hold. Last one. Okay, shake out your arms to get some blood flow. Shake out your legs. Okay. Let's roll our shoulders a little bit. They're probably a bit tight, hunching over. So roll them back, roll them forward. Okay. Let's do some small circles. Feel your shoulder blades, and then into big circles, like you're swimming the butterfly. And I want you to change direction, like you're doing, I don't know, some funny backstroke. And then I want you to come down to smaller circles again. Okay. Shake out your arms again. Shake out your legs. Let's do some rotation. So gently on your hips. And you're only going to go a little way initially. And then as you become more relaxed, you should find your body is loosening up. And you'll feel that, yeah, you'll go further. Okay, and then let's do a tricep stretch. Again, you'll feel a bit of tightness. That's fine. You've probably been hunching over. I'll switch to the other side. And then shake up those arms one more time. Okay, we're just going to do some air skipping to get the blood flowing. And, you know, it's just a skip without a skipping rope. And we start in 3, 2, 1. Let's go. Halfway. 5 more. And stop. Okay, so let me know in the chat how your body feels. I know my body feels like my attention span has been somewhat reset. Let me know if you feel some of the same phenomenon going on for you. Maybe you can even convince your teacher in class to take it up. I'm not going to do Maths 24 today, so my apologies to all the big Maths 24 fans, but I think we've just haven't got enough time today. So let us go to another question. Okay, so for this question, let's start by introducing ourselves. And I would advise doing this in your test, because one of the things I've noticed with students is that visually there's so much information that they get a bit like overwhelmed sometimes. So what I noticed is helpful is you must introduce yourself. So you say, TD is a tangent to the circle ABCD. And so where is TD? Just so I know what I'm dealing with. Okay, there it is. So there's a tangent involved. And I'm thinking, what are the theorems that have to do with tangents? Then AD is parallel to BC. So they haven't actually put this on the drawing. So I'm going to put it on so that I don't forget. So, and I'm even going to label them with little arrows. Okay, so I've done that. That AB is produced, not a problem. TBS is a straight line. Then it says, if this is equal to this, and I go and look, where is WBT? So WBT and CBD, oh, that's why there's little dots. Now, what I find is helpful is when they have these little dots, I just make these things equal to X. So I say let WBT equals X. And it's just a helpful way. You don't have to do this, but I'm going to make that X and that X on my drawing so that if I want to show relationships, I don't have to write down these long angle things here. It just makes life a bit easier if I have some sort of symbol language that I can use. Okay, I want you to try and prove that WBWTD is a cyclic quad. And again, to help my brain, I'm going to actually highlight where this thing is. So BWTD. So what we notice is that is the area that we are playing with. That's what we're trying to, work with. So give it a go, give it some time. We're not going to rush this type of question because it takes more, just a bit more thinking and processing. So Paul, I see your question in the chat. The order doesn't matter as long as the logic is sound. So it wouldn't matter what order you find it in, no. Oh. Okay, so Carol, be careful. DWT doesn't equal X yet because we don't know this is a cyclic quad. If we prove it's a cyclic quad, then we know it's X. But at the moment, we don't know that a circle will actually fit through these 4 points. It may be that it's not possible. So we can't use the fact that it's a cyclic quad before we proved it. When we think of the 3 options we have, I think we have converse opposite angles cyclic quad. We have converse exterior angle cyclic quad, or we have converse angles in same segment. I'm just writing quickly, I'm not doing it long way, but so those are my 3 choices. And the question is, what information could help me? I don't want to forget the fact that there's a tangent involved here. So there is a cyclic quad that we can see, ADCB or ABCD, but there's also a tangent. So Fazama has said B3 is equal to D3. Ooh, that's interesting. You're correct. So that, I don't know if it helps us now, but it's something to point out. And the reason I think Fazama knows that is because of the alternate angles. So that's something to remember for later. But I don't know if it helps us write, unless I'm missing something, if the goal is to make this thing here a cyclic quad. Is it just me, or do I see a bit of butterfly going on in the green thing? So I'm thinking, I mean, I suppose I could try and show that B4 is equal to T. Okay, TWD. The problem, Trishan, is that this isn't a cyclic quad yet. We need to show using other stuff that this is a cyclic quad. So what I was thinking is, if we could show that like this angle is equal to this one, or this one is equal to this one, or so on. I'll give you a hint. Think about the tangent. What do you think the tangent gives us that might be helpful? So if we have this angle here, what does D1 equal to? So I think we can say that D1 is equal to B3, and that will be equal to X using our naming convention. So I think this one over here, and the reason is tan chord theorem. Now, what does that help us with? If we know that that's X, does that help us? I'll give you a little, it's all about, this is where colors help so much. Yeah, I'm definitely taking you to the gym now, but I've highlighted those two. Yes, Naledi. Yes, 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 yes. Can you see that these wings, these are hiding the D1 and the B1? So this is the converse angles in the same segment. So how do we write this up? So we say D1 is equal to B1 is equal to X, and we've already proven that. So that's where it's nice to use X's, because we've shown that already. Therefore, BWTD is a cyclic quad, and the reason is going to be, yep, converse angles in same segment. And therefore, we've proved that a circle could fit through here. Okay, nicely done. Now, the next part of the question is to show something is a tangent to ABCD. Fateko was asked, do you have to say converse? Yes, you do have to say converse, because otherwise you get confused with the normal angles in the same segment. Okay, describing what converse means, it's basically, the technical way would be to say, if P implies Q, the converse is Q implies P, but that sounds a bit like, ugh. So it's like saying the original theorems, you assume that there's a circle and a tangent. And if you see that, you use the tan chord theorem. The converse of the tan chord theorem says you've got a line and something, prove that, and a circle, prove that that's a tangent, and it goes the other direction. Okay, but I don't think there's time for me to go into too much detail, otherwise I'm going to get sidetracked. But it's basically, you use the converse theorems to prove tangents exist, to prove cyclic quads exist, and so on. Okay, now, I'm going to move this working out the way, but I want to think about how do we prove something is a tangent? And where is the line that we are talking about? So let's take a moment and make sure we know which line we are referring to. And it says ABCD is this, TBS. Where is TBS? TBS is this line. Now, how do we prove that something is a tangent? What are the three, or well, only two ways, but I don't see a center of the circle. Now, if there's only two ways to prove that it's a tangent, and one of them is not here, it's either tan chord or tan radius converse, right? But can you see there's no center of the circle? So if there's no center of the circle, my money is on converse tan chord theorem. That's what I think it has to be, because otherwise, how else am I gonna do it? I know that the blue is the line that I have to do. So either I need to show, well, that's hard, but I was thinking, if I can show, like, which one should I focus on? I was thinking we should focus on, like, either show that this bit here, so either show that is equal to that, or show that this is equal to this. Now, I want you to think about Can you follow my logic there? It's like we have the tangent. I can't, or maybe I could show that this one over here is equal to that one over there. That would also do it because there's the line, there's the chord. So any of those are possible. See what you can find. But remember, you have to use what you've got so far. But the one thing that I haven't, maybe I should bear in mind here is you have proved in the previous question you have a cyclic quad. So you can use the fact that this green thing is a cyclic quad, if that's helpful to you. Does that make sense? Like you have proven beyond any doubt that this green thing is a cyclic quad. So because of your hard work, if you need to, you could use that as part of the next question. Oh, and I remember earlier, didn't we prove that this one over here was equal to x earlier in the thing because of alternate angles? So I know actually earlier on we proved that. How do we know B4 is x? How do we know Karabo? How do you think? There's probably a couple of different ways we can do this. Oh, the other thing is, couldn't we say, I think we need to use these corresponding angles. I feel like they're not getting the airtime. You know, they wouldn't have given us these parallel lines unless they were useful for something. So let's actually focus on that for a second. B3 is equal to D3 by alternate angles. Yep. Although I was thinking, I don't know if you can see this. Can you guys see like the F shape? Now, there's many ways to do this, and we're running out of time, so I do want to make sure we finish off today. But can you see that this bit, I should use a different color. Let's use, can you see that there is parallel lines going here? And to me, it feels like B1 and B2 will equal A. Actually, you know what? We're running out of time. Let me put the whole answer up for you so you can have a look at this, and then you can actually look at the, oh, wait, let me bring that back. There's a couple of different ways you can do it. Let me put this up so that you can have a look now as we finish off. Don't worry, Fateko, the quiz isn't so bad. It's just, I'm pushing you a little bit. So if we look here, what they say in the answer here is B1 plus B2. Okay, B1 plus B2 is what I was trying to show you here. And B1 plus B2 is equal to A because of corresponding angles. Okay, so that is equal to that. But we know B3 plus B2 is equal to B1 plus B3 because we actually were given that at the very beginning. So at the very beginning, we said B3 is equal to B1. That was actually what we had. We know that this and this is equal to that, okay? Therefore, A must be equal to B3 and B2. Okay, Awami, don't worry. Okay, let me, how much time have we got left? Okay, all I want to say to you is look at the answer there. Let me get rid of all this stuff, which is confusing you. So just stay with me for a moment, and then we'll tee off for today. Are you happy that this angle over here. This yellow is equal to A. Give me a thumbs up if you're happy that that is equal to that from the fact that there are corresponding angles. Okay, so you're with me. So here's your F shape. Now, this is a tricky question, I agree, but sorry, that's not the right thing. Okay, now, are you happy? Okay, so that was the first bit. Are you happy that this one over here is equal to this one over here because they tell you at the very beginning? So that's this bit here, B1 equals B3. Can I get a thumbs up for that? Okay, so then if we know that this and this, okay, so if we know this and this is equal to like that, and we also know that this and this equal to that, we can say that B3 plus B2 must be equal to angle A over here. So that's the bit over here where maybe I'm losing you. If you watch the video again, it'll be fine. But basically, we basically saying that these two over here, we're deducting that this over here is equal to this over here. And that is the angle between the tangent and the chord, or the line and the chord equals the angle in the alternate segment. So that's what we were trying to do. So TBS is a tangent, converse tan chord theorem. Now that was a tough question, I don't deny it, but I need to push you guys a little. Okay, so what I suggest is rewatch this video again for the last bit,